just a short video about row echelon form and reduced row echelon form. Row echelon form is the goal of Gaussian elimination on a matrix. It's a slightly more general thing than the triangular form we were thinking about for systems. And the key concept for both of these guys is the leading entry, or the pivot, as I often call it. So this guy is the first non-zero entry in its row. It's a leading entry. This guy is the first non-zero entry in its row. It's a leading entry. And this one is the first non-zero entry in its row. That's a leading entry. So you first start looking with a sort of a row-based attitude. You look row by row and you identify those leading entries. And then you ask, how do they sit in their columns? Do they go from left to right as we go down the rows? And the answer is no here. Okay, so this is not in row echelon form. One of the conditions for row echelon form is that we need, the first one is that we need the leading entries go left to right as we go down the rows. Or another more precise way to say it, the way the book says it, each leading entry is to the right of the leading entry in the row above. Remember, leading entries, you have to look for the first non-zero entry. It's not always just down the diagonal. This guy here is not a leading entry. It's not a pivot. A zero can never, ever, ever be a pivot. Okay. The other condition is a little bit more minor. Let me show you another one that's not in row echelon form. Let's suppose this was 2 still. Let's suppose these were all zeros. That's another one that's not in row echelon form. It's got a row of zeros. It's a really important thing about a matrix. It's a 0 equals 0 equation. That's a huge signal. And just to standardize things, to make things really, really cut and dried, we don't want that to be in the middle. We want that to be at the bottom. So this is, again, not in row echelon form because the row of zeros is not at the bottom. So the second thing that we need for row echelon form is that if there are any rows of zeros, any row which is entirely zeros must be at the bottom. There's nothing super hugely important about that in the grand scheme of things, except that we want to make this very, very standardized, so that we all can compare answers human to human, and also so we can compare to what a computer does, and we can program a computer or a calculator in a simple way. And also it's really handy for proving theorems and really getting to the theory of this stuff. It's not just for computations. So that's what I need for row echelon form, not reduced. The leading entries go left to right. It's sort of a stair-step pattern, and any row which is entirely zeros must be at the bottom. Okay, below any non-zero rows. Okay, so one that is in echelon row echelon form would be like this. That guy. Now this guy is a pivot because it's a leading non-zero entry. Okay, that's an augmented matrix for a 3x3 system that is in row echelon form. So this is in row echelon form. But because it's doing the stair step, each pivots are going from left to right as we go down. There's no zero rows, so that the second condition doesn't apply. But it's not in reduced row echelon form. Okay. The reason for that is there's one other thing, or two other things rather, we need for reduced row echelon form. And to be honest, the book, yeah, let me actually clarify something. I forgot to clarify it already. The book requires, this is a difference of opinion among people who write linear algebra texts. The book would say this is not in row echelon. This is in it's not in row echelon form because these are not ones. So I think the majority of people actually take the other convention. The other two things we can ask Number 3, this is different from the numbering in the book because I'm talking about a slightly different variation of the concept, is that all leading entries are equal to 1. So when you look at the answers in the back of the book, they're going to require this even just for row echelon form. And I don't agree with that. I don't think that's really essential for row echelon form. But it's a good thing to have to simplify your matrix. And certainly for reduced row echelon form, everybody agrees that those leading entries, the pivots as I often call them, should be equal to 1. And the fourth thing, the really important thing, is that every other number sharing a column with a leading entry is 0. The way I like to say it is these pivots are tools, these leading entries are tools that can be used to kill other things. Like this 5 has not been used yet to kill this 1. So something that would be in reduced row echelon form would be something, for example, if this were 0 and these were 1s. Okay, that's reduced row echelon form. This is in reduced row echelon form, or rref for short. If this guy was non-zero, that's okay. This guy does not have to be 0 because there's no pivot in this column, and that's going to be very important for us. There's no pivot in this column, and so it doesn't matter if this guy is 0 or non-zero. Now, of course, this guy can't. If this guy were non-zero, it would be the pivot. But given that here's a pivot, here's a pivot, here's a pivot, these leading entries are here, they're equal to 1, and oh, just kidding. Yeah, there we go. Sorry, that's in rref. I got focused on this guy, and then I forgot these guys. Finally, this guy is in reduced row echelon form. So it wasn't quite yet before. But now I check the pivot columns, and there's nothing but 0s and a 1 in the pivot columns. And in a non-pivot column, it's not as important. So that -5 can be there, but that's pretty much the only non-zero entry that can survive besides the pivots in this particular form. Okay. So another example would be, let's just do a bigger matrix. If you've got the idea, you can stop watching now if you really want to. But let's do like a 4x5. So, for example, 1 minus 3, 0, 2, 0, 0, 0, 1, 0, or let's say -4, 0, 0, 0, 0, 0, 1. So this guy is in reduced row echelon form. It's got, we identify the pivots, the leading entries. There's 3 of them. And in the pivot columns, it's nothing but 1s and 0s. The pivots are going left to right as we go down. There is a row of 0s, and it's at the bottom. So by my definition, or by the book's definition, it's definitely in row echelon form. And it's reduced because there's these extra 0s above the pivots. And one interesting thing about this guy, what kind of system does this encode? It encodes an inconsistent system, because this says 0w plus 0x plus 0y plus 0z equals 1. And it tells us that having a pivot in this right-hand column, the column of constants for an augmented matrix, is not a good thing if you want to find a solution. So this guy, again, is in rref, because we've checked all the conditions.